Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P0172-00, indicating a fuel system too rich error specifically for the Honda CR-V models from 2023 onward. DTC stands for Diagnostic Trouble Code, which helps identify issues in vehicle systems. The P0172 code specifically suggests that the engine control unit, or powertrain control module, PCM, has detected an imbalance in the fuel-air mixture, indicating that the engine is receiving too much fuel. Understanding this DTC requires familiarity with components such as the manifold absolute pressure (MAP) sensor, air-fuel (AF) sensors, fuel injectors, and various sensors that contribute to the vehicle's fuel management system. Each of these components plays a crucial role in ensuring optimal engine performance and fuel efficiency. Incorrect readings from these components can lead to complications such as increased emissions, reduced engine performance, and potential engine damage if not addressed promptly. The error description for DTC P0172-00 indicates a fuel system too rich condition, which means the engine is receiving excessive fuel compared to the amount of air. The powertrain control module, PCM, monitors the long-term fuel trim, LTFT, and when this value falls below a specified threshold, the PCM stores the DTC. Critical components involved include the mass airflow, MAF sensor, located in the intake system, which measures the amount of air entering the engine, and the AF sensor that monitors the air-fuel mixture in the exhaust. Both sensors work together to maintain an optimal fuel mixture for combustion. Additionally, other related components, such as fuel injectors, the fuel rail pressure sensor, FRPS, and the engine control unit, ECU, must be in optimal conditions to ensure rich fuel mixture detection does not occur falsely. An accurate diagnosis requires careful inspection of these components in their respective locations. There are several possible causes for the DTC P0172-00 that need to be systematically investigated. Firstly, modifications or aftermarket components in the fuel system, such as non-OEM fuel injectors, can lead to excessive fuel delivery. A faulty mass airflow (MAF) sensor may compromise the engine's air measurement, causing an incorrect air-fuel mixture. Similarly, a malfunctioning AF sensor can misinform the PCM about the combustion process, resulting in an overly rich mixture. Fuel injectors that leak or fail to close properly can unintentionally flood the engine with fuel. Additionally, contaminated engine oil due to faulty injectors might affect engine performance and lead to erroneous readings from various sensors. Each of these components can individually or collectively contribute to the DTC P0172-00, making comprehensive investigations crucial. When DTC P0172-00 is triggered, drivers may note various symptoms indicating an issue with the fuel system. A common symptom includes poor engine performance, characterized by sluggish acceleration or rough idling, as the engine struggles with excessive fuel. Another symptom is increased fuel consumption, as the vehicle operates inefficiently due to the rich mixture. Additionally, the vehicle may fail emissions tests due to elevated levels of unburnt fuel going into the exhaust, contributing to air pollution. Drivers may also observe black smoke from the exhaust, a visible indication of an overly rich fuel mixture and indicative of combustion inefficiencies. Recognizing these symptoms can help to rapidly identify and troubleshoot the underlying issues associated with DTC P0172-00. In the first troubleshooting step for addressing DTC P0172-00, start the engine and allow it to idle without any load, meaning the vehicle should be in park or neutral. Monitoring the Honda Diagnostic System, HDS, is crucial at this stage. Specifically, check the short-term fuel trim, STFT value, noting that if it is less than 0.79, this indicates a duplication of the failure, confirming that the vehicle's fuel system is indeed experiencing a rich fuel condition. This step is significant as it establishes a baseline for the engine's performance under controlled conditions, allowing technicians to assess the fuel management system comprehensively. If the situation verifies the DTC, technicians can proceed to further detailed inspections based on this confirmation. The second troubleshooting step involves reviewing the Honda Diagnostic System (HDS) onboard snapshot data recorded when DTC P0172-00 was initially stored. It is important to document the value of the short-term fuel trim (STFT) at that time. Following this, conduct a test drive under identical conditions to those present when the DTC was triggered. Factors such as engine speed, vehicle speed, throttle position, and accelerator position must closely mirror those from before. This will provide insights into whether the STFT fluctuates during normal operation. If the STFT value exceeds 0.79 during the test drive, it reconfirms a sustained rich condition, validating the issue represented by DTC P0172-00 and guiding the technician towards further diagnostics. In the third troubleshooting step for DTC P0172-00, fuel pressure testing becomes critical. Start the engine and maintain the engine speed at 3,000 RPM without load until the radiator fan activates, ensuring the engine is operating under a stress-free condition. While the engine is running at this speed, the next step is to conduct the fuel pressure test using the Honda Diagnostic System, HDS. Qualified technicians will evaluate gauge readings to determine if the fuel pressure remains within normal specifications during this step. Confirming normal conditions regarding fuel pressure is paramount, as an abnormal reading may point to potential issues within the fuel supply system, including the fuel pump and fuel pressure regulator, which could easily lead to a rich fuel mix. During the fourth troubleshooting step for DTC P0172-00, the inspection of the mass airflow (MAF) sensor is essential. Start the engine and allow it to idle while ensuring that it meets specific conditions. The engine coolant temperature (ECT) sensor must exceed 176 degrees Fahrenheit. The transmission should be in park or neutral, and all electrical loads must be switched off. Maintain the engine speed at 2,500 RPM for 30 seconds, monitoring the HDS for MAF sensor readings while doing so. Normal values during this testing period should range between 4.1 grams per second and 5.7 grams per second. If readings fall outside this range, it indicates potential malfunction of the MAF sensor, which could be influencing the rich fuel mixture and confirming the underlying cause of DTC P0172-00. Step 5 in addressing DTC P0172-00 involves inspecting the engine oil for fuel contamination. Start the engine and allow it to idle before gently pinching the positive crankcase ventilation (PVC) hose. This action temporarily alters the pressure within the crankcase, which can help in observing the short-term fuel trim STFT values. If the STFT value remains below 0.79 under these circumstances, the engine oil is likely uncontaminated. However, if the STFT does not conform to expected levels, this may suggest that fuel is contaminating the oil, potentially stemming from faulty injectors. Additionally, if oil contamination is confirmed, immediate action is required to replace the engine oil and oil filter to prevent long-term damage to the engine components. The sixth step in troubleshooting DTC P0172-00 is to thoroughly inspect the evap canister purge valve. First, Disconnect the 2-pin connector of the purge valve and detach the vacuum hose leading to the valve. Connect a vacuum pump with a gauge, 0 to 30 inches of mercury, to the purge valve. Start the engine and let it idle, carefully monitoring the gauge. Under normal conditions, there should be no vacuum present during idle. If any vacuum is detected, it indicates that the purge valve may be malfunctioning, allowing excess fuel vapor into the intake manifold. These conditions can significantly affect the air-fuel ratio, contributing to the rich mixture and triggering the DTC P0172-00. Properly diagnosing this valve is crucial, as it plays an important role in the emissions control system of the vehicle. In the 7th troubleshooting step for DTC P0172-00, a thorough fuel inspection is warranted. Given that there is no direct testing method for fuel quality, the procedure necessitates replacing it with a known good fuel source. Begin by draining the existing fuel from the vehicle's tank and refilling it with quality, trouble-free fuel. Observing whether the original symptoms or DTC code reappears is key. If the failure is replicated after this step, it suggests that the cause lies within other related components of the fuel system. However, if the DTC P0172-00 or symptoms disappear, it indicates that the initial fuel could have been contaminated or degraded, emphasizing the importance of high-quality fuel in maintaining engine performance and efficiency. The 8th troubleshooting step for DTC P0172-00 involves inspecting the AF sensor, Sensor 1. Since there is no straightforward testing method for this component, the approach typically involves installing a known good AF sensor and attempting to reproduce the failure. This step is crucial, as a faulty AF sensor cannot accurately determine the air-fuel ratio during combustion, often leading to a rich fuel condition. If the original DTC is triggered again, it indicates issues with components outside of the AF sensor itself. Conversely, if the DTC does not reappear, it likely confirms that the original AF sensor was defective and should be replaced to restore proper fuel management. The 9th step in troubleshooting for DTC P0172-00 involves a detailed inspection of the fuel injectors. Similar to the previous inspections, this procedure requires the installation of known good fuel injectors to determine whether they are functioning correctly. Fuel injectors are responsible for delivering precise amounts of fuel into the combustion chamber, and a malfunction can easily lead to a rich condition. If replacing the injectors does not restore normal parameters and the DTC persists, the issue may lie elsewhere within the fuel system's components. Properly diagnosing fuel injectors may involve assessing their electrical connections, resistance, and visual conditions to ensure that they are within standard operational specs and to determine if they require replacement. In the final step of troubleshooting for DTC P0172-00, the inspection of the Powertrain Control Module, PCM, is necessary if all preceding inspection items have returned normal values. The PCM is the brain of the vehicle's engine and fuel management systems, integrating input from various sensors to determine optimal operating conditions. If all other components prove functional and the issue persists, it is likely that the PCM itself is at fault. Establish the PCM's condition through diagnostic checks and signal responses. Should the PCM be confirmed as faulty, replacing it becomes the final course of action to resolve the DTC P0172-00 and restore the vehicle to its proper operational state. Following the completion of all diagnostic and repair procedures for DTC P0172-00, verifying the repairs is crucial. Begin by clearing the DTC from the PCM and then conduct a test drive under various driving conditions to ensure that the fix has correctly resolved the original issue. During the test drive, closely monitor the short-term fuel trim (STFT) values to ensure that they remain within acceptable limits, ideally above 0.709. If the values stabilize, it confirms that the corrective action taken addressed the causes of the rich mixture effectively. Should DTC P0172-00 not reappear and STFT values return to normal, the vehicle can be deemed resolved, ensuring that the customer experiences optimal performance and fuel efficiency. To prevent the recurrence of issues associated with DTC P0172-00, implementing regular preventive maintenance procedures is essential. Conducting thorough checks of fuel quality ensures that only clean, non-contaminated fuel is used in the vehicle, which helps preserve engine performance and longevity. Additionally, periodic inspections of key sensors, including the MAF and AF sensors, can help identify any performance degradation before it leads to extensive troubleshooting. Regular engine oil changes are equally important. Contaminated oil can negatively affect sensor performance and overall engine function. Finally, maintaining the vehicle's vacuum and fuel systems through visual inspections and performance checks will aid in identifying potentially faulty components, ensuring reliable operation and optimal fuel economy long-term. In conclusion, tackling DTC P0172-00 requires a thorough understanding of the factors contributing to rich fuel conditions and systematic diagnostics to isolate the root causes effectively. Each component, from sensors to fuel injectors, plays a significant role in maintaining balanced air-fuel mixtures, allowing technical professionals to deploy targeted solutions based on observed phenomena. The importance of performance monitoring cannot be understated. Remaining vigilant post-repair ensures that any reoccurrences can be promptly addressed. Lastly, implementing preventive measures will maintain vehicle health, ideally extending its lifespan and improving overall efficiency. By adhering to these guidelines, technicians can ensure that vehicles operate smoothly and efficiently while successfully managing DTC P0172-00 related concerns. Please like and subscribe to the channel. See you next time.